Hi guys, today we're doing vertical projectile grade 12 revision. We're going to be going over the concept that you need to remember before you write your examination. Right, the first part is what is vertical projectile motion. It's mainly important to know your definitions as they do contribute marks. So vertical projectile motion is the one-dimensional straight line motion of an object under the sole influence of gravity. So we're looking at the motion in which it relies solely on gravity, right? And there are key concepts in vertical projectile that some students tend to mix up. The first one being projectile. Projectile itself is any object that is being thrown or launched, meaning that this object has V initial. Now, but in the case of the object being dropped, this means that object doesn't have V initial, but its V initial it's zero because it's dropped. Now the second part is the vertical motion, whereby we consider up or down. For now, we're just going to consider up and down because sideways it's not common in the exam papers. Then the last part, which is acceleration due to gravity. This one we already knew that it's 9.8 meters per second squared. Always acts downwards. Don't make the mistake of considering it acting in a different way. Then there are equations that you can use in order to solve the vertical projectile problems. The first one being the velocity time equation, which is v is equals to u plus gt. Now I know the way I've written it, it's not common because in some textbooks they write it as vf is equals to vi plus g changing t. Now what I've written here is still more or less the same, it's just an older version. So for us, v is the final velocity and the u is the initial velocity. The g is the gravitational acceleration and the t is the time, right? So while we're here, acceleration, guys, I didn't write this gravitational acceleration here because there are some cases whereby you're required to calculate your own acceleration. So in that case, it's mainly that object is not in a vertical projectile motion. So other formulas that we can consider under this are the displacement time equation, velocity time equation, and the maximum height equation. So you're more than welcome to look at these formulas also, to consider them. Now there is a fourth one, but it's not commonly used. It's the average velocity formula, but then for now we're not going to consider it because of some of the cases. But if it do comes up, we are going to attempt it, if it do comes up on the problems that we are going to be attempting. Right, now let's look into an example that we have, right? So the example that we have is this one. So an object is projected vertically upwards, right? Now it's projected up, okay. Now 4 seconds later, it is caught at the same height on its way downwards, right? So it was caught at the same, basically it was caught at the same height at which it was thrown. Now they want us to determine how long it took the ball to pass the height of 8 in the upward direction, right? Now from there on, they say choose downwards as the positive direction. So we've even been given the reference direction. They only want you to take down as positive. Now, in most cases, sometimes you won't be given this opportunity, but for now, we're just gonna listen to them, right? So now, since we have been given this, I want us to look at the given data, which is mainly important in physics, right? We have to know what we have been given. So first part, we know that it is projected vertically upwards. This means it has a V initial. We have to find that V initial, right? I'm assuming. The second part is it took 4 seconds to reach the ground, right? So it took 4 seconds to reach the ground, and deadly, it's the height is 8 meters, right? And the last part is what? Downwards is positive. So in this case, since we have this, we have to draw out the situation of what is happening. It's mainly important to have a sketch of what is happening. So this is the way I drew the situation of what is happening in this problem, whereby since the ball was thrown from point A to point B and it was caught on the same height at which it was thrown, it's more of like a parabolic nature, right? So it's mainly important to have the sketch. Right, now let's start into solving this problem. Now, firstly, let's find the initial velocity, right, by looking at the pathway in half, right? We're just going to consider how 1/2 of the pathway. Now, from there on, we're going to look at the max height. The reason why, it's because we know that at the maximum height, the final velocity is what? Is 0, right? Because if we know that the VF is 0, then we can then find the V initial, since we have the time it took, right? Which is 2 seconds in this case. So we're going to use the velocity time equation. Then we're going to write it out. It's important to write your formula, whereby the VF is 0, like I said, and our substitution will be like this. Now, for someone who's wondering where did you get the 2, please remember that they said the total path, the total duration of this pathway took 4 seconds, right? So mainly it's going to be 2 seconds if we're considering 1/2, right, of this pathway. So from there on, when I solve this, I get u as negative 19.6 meters per second, telling me that it is correct because it's going up. It has to be negative if it's going up, because downwards is considered to be positive. As I've written here, negative suggests that the object is moving up, which is correct, right? Now, from here on, we then have to find the time now, right? By using what? By using the displacement time equation. So the displacement time equation is S is equals to U t plus 1 over 2 at squared. So after writing out the equation, we're then going to substitute what we know, right? We do have the displacement, which was 8 meters above the ground, and we have to write it as a negative because it's above the ground, right? And we do have our initial velocity, which is negative 19.6. Please write that negative. Doesn't mean that if it's negative, we know that the direction is up. You can just neglect it. Please write it. And then you're going to be having 4.9 t squared, right? Which is like that. So after substituting like this, you can then rearrange the formula or the equation itself. You're going to have 4.9 t squared minus 19.6 t plus 8, which is equals to 0. Now, for those who love maths, they know that this is basically a solve for x equation, but then in our case, it's just going to be solve for t, right? So you're going to use the quadratic equation, which is going to be like this. After using the quadratic equation, you're going to substitute your values and find your t as 0.46 seconds, or t is equals to 3.54 seconds. Now our answer here is going to be the 0.46 seconds. How do I know that? It's because we're just going to consider the first part of it, right? Because the question asks us to find how long did it take it to reach the maximum height, which is the 8 meters per second. So that's the only part. That's the only time that we're going to take, right? So we've reached the end of this video. If you want more activities or more revision activities, you are more than welcome to check out the playlist that is linked below. And if you have any questions, you leave them below in the comment, or any question that you want me to attempt, you can send it through on my email through that I've put in the about. Guys, I'll see you in the next one.